Howdy, today on Flipping Science we're going to look at the advantages and disadvantages of synthetic plastics and types of polymers.
There's a hole in my bucket, dear Liza, dear Liza. There's a hole in my bucket, dear Liza, a hole. Then mend it, dear Henry, dear Henry, dear Henry. Then mend it, dear Henry, dear Henry, mend it. With what shall I mend it, dear Liza, dear Liza?
So Science Understands we're going to look at. Production of synthetic polymers allows the manufacture of materials with a diverse range of properties. So discuss the advantages and disadvantages of synthetic polymers. Polymers are produced from monomers. So identify whether a molecule can undergo polymerization given its structure, and if so, what type of polymerization it will undergo, so either addition or condensation, and also identify the repeating unit of polymer given its formula. So why are plastics important? And a good way to look at this is to think about buckets. So buckets used to be made out of metal or wood in some cases, and they'd be quite expensive. They'd be quite an investment for a person. So if you've got a hole in a bucket that was made out of steel, you would have to go and get it repaired. You'd have to cut out a piece of metal to cover it over. You'd have to weld it in or stick it in some way over the hole so that the bucket didn't leak anymore. With plastics, we don't worry about that. If you get a hole in your plastic bucket, you just throw it out and buy a new one because plastic buckets are relatively cheap. So we can see kind of the advantage of plastic here in that it's much cheaper than the material that used to be used. If it's relatively disposable, it can be recyclable, and it can be relatively easily recyclable. So there's some advantages there. Disadvantages for plastics, well, it can be quite wasteful when you produce a lot of plastic that's used once and then thrown away if you don't recycle it. You can look at the petrochemicals that are often used to make plastics could be used for other purposes. They could be used to develop medicines, for example, or they could be used as a feedstock in lots of other industries. They could be used as fuels even. So the use of plastic has advantages and disadvantages, and you need to come up with a bit of a list of why plastics are good and why plastics are bad. So what makes a plastic? Well, plastics are polymers, so they're made up of many repeated structural units which are called monomers. So the polymer, poly means many, is made up of many monomers, mono meaning one. To figure out what the monomer is, you need to look at the repeating units that are involved in the polymer and see if you can figure out where they come from. For some of them, it's relatively easy. If you look at, so PVC over here, so polyvinyl chloride, if you look here, you can see here's your structure of the polymer, and you can see the bit that is repeating. So if we needed to, we could put a bracket around the repeating unit to show the structure that is repeating. Similarly with polypropylene and polystyrene over here. The repeating unit, it's been highlighted in red here, you can see the repeating unit of polypropylene and polystyrene. There are two basic ways of producing a polymer. There's addition reactions and condensation reactions. So in addition reactions, you are usually just breaking a double bond somewhere and joining the monomers together at the point where the double bond breaks. With condensation polymers, you get a small molecule being emitted when your monomers join together. So if we look at the structures of some of these polymers, we should be able to figure out how it's been produced by looking at the structure. So we'll start up here with PET. This could be used to make plastic bags, for example. If we look, we can see we have kind of one big unit here that involves a benzene ring, and then we've got a kind of a small unit in the middle that's got a couple of carbons in a chain, and then it goes back to the benzene ring. So we've got two different monomers here that are making this up. We've got a carboxylic acid, it looks like that's attached to the benzene ring, so it's a dicarboxylic acid, and in the middle we have what would have been from an alcohol. So we've got an ester group in the middle here, so C double bond O to an O, so C to the O to the C double O, okay? So we've got an ester group. So that tells me that when this joins together, we're going to get a small molecule coming out, because whenever you do esterification, you get a water molecule that's being emitted. If we look at polystyrene down here, they've been nice enough to give us a copy of the monomer, and we can see the double bond between the carbons here. So the double bond breaks, and we join on at the break to another styrene molecule. So we can see where it's joined together. So because we're not getting a small molecule that's being emitted here, that's just an addition polymerization. If we look at cellulose down here, now cellulose when you join the glucose monomers together, there should be a hydrogen here, and on the other side there should be an oxygen and a hydrogen. So we're getting, at this point here where the monomers join together, we're losing 2 hydrogens and an oxygen. And that tells me that that's a condensation reaction because you're getting a small molecule that's coming out. If we look down here at PTFE, which is polytetrafluoroethylene, yes, it's also known as Teflon. There's only one thing in here, so we would have a double bond that would be in the monomer, and that would be snapping and joining on to the next monomer. So here are some example questions. The first one says polypropene is an example of a synthetic polymer. It's produced from propene gas. Draw the structural formula. So based on this, draw the structural formula of a section of polypropene that shows at least 2 repeating units. So first thing I'm going to do is I'm going to draw the polypropene in a slightly different way. Okay, so we've got C, double bond C to C, then I need to put my H's on. So then I've got one H over here, one H over here. I've got an H, so 1, 2, 3, so I've got an H up here, and then down here I've got 3 H's. If I draw it like that, I can kind of see where it is going to join on in a little bit of an easier way. So I'm going to snap this double bond here, I'm going to move that bond over here, and then I'm going to join it onto the next propene molecule. So now I'm going to draw it slightly differently. I'm going to have my carbon going to my carbon, so that's this bond here. I'm going to have that going down to this carbon down here, and now I'm going to join on to the next propene molecule. So there's my C, I'm joining on to the next C over here, and then I'm going to go down to my other carbon down here. I'm going to draw one more just so I can make sure that I get it right. It says it shows at least 2 repeating units, I'm going to show 3. And now I need to put in my H's. So that's going to continue off to that side, that one's going to continue on over there. So now I need to make sure I've got enough H's in to satisfy each carbon having 4 bonds. So there we go. So we can see what the repeating unit looks like. So that's this central unit here, that's the repeating unit, and I've put 3 together just so I can make sure I get it right. Second part of the question says identify the type of polymerization reaction by which polypropylene is manufactured. All I'm doing is breaking a bond and then joining one monomer onto the next. I'm not getting a small molecule that's being emitted, so that means this is an addition polymer. So I'm just going to write in addition. The next question says, talks about Kevlar. So the first part down here, so we've given some a diagram of Kevlar. It says circle an amide group. So to find an amide group, C double bond O NH. So here we have an example amide group. Right, and it says name the type of polymerization. Now what I'm going to do to make this easier is I'm going to circle the repeating unit. So I'm going to use some brackets here to show what the repeating unit is. And then I'm going to draw over here what the monomers would look like that make this. So we've got a benzene ring in both of them. So forgive my hexagons. Wonderful. All right. Now the first one over here, if we look at this, the benzene ring goes to an NH. So I'm going to go to my N. Now it wouldn't go to 1H in the monomer, it would go to 2. So we'd have a diamine or a diamino. So that would be my first monomer here. If we look at our second part here, attached to the benzene ring, we've got C double bond O. You never get C double bond O by itself. That would be a carboxylic acid group. So we've got C double bond O, and that would go down to OH. And that would be the same on both sides. OH. All right. So we've got a diamine and a dicarboxylic acid. Whenever you react an amine with a carboxylic acid, you get an amide group forming. And you lose this H here, and you lose that OH there. So if you lost 2 H's and an O, that makes a water molecule. So whenever 2 of these monomers join together, you get a water molecule coming out. So that makes this a condensation reaction. So write that in. All right. Next question says, in one method, nylon 6 is produced by polymerization of this monomer. State the type of polymerization. Now again, we've got a carboxylic acid over here and an amino group over here.
So when they join together, you're going to get water coming out, so that's going to be condensation. And my explanation there. So then it says stated reason. So like I said, you've got a carboxylic acid reacting with an amino group to produce an amide group. When that happens, a water molecule is emitted. So a small molecule is emitted when the monomers join together, and that makes it a condensation reaction. That's it for Living Science today. See ya.